So today we're going to look at using the TN formula, how sometimes it's not always the best option, and then we're going to look at some equations from words, so how to figure out how to pop this information into our TN formula. Okay, so we have here Carla and Liam walk to school. Carla lives 500 metres from school and Liam lives 600 metres. Carla can walk 100 metres in 1 minute and Liam can walk 150 metres per minute. Write a formula that represents their journey to school. The first thing I would do here is just draw a little graph that will help us. So we will just, a little table I suppose. So we'll put time here on top, because what we want is we want to write out our sequences, because that's how we know how to use the TN formula. So you have Carla and Liam, and what I'm going to put across the top here is the time. So at 0 minutes, both of them, so that's when they're at their homes, we know that Carla's 500 metres away and that Liam's 600. And after 1 minute, looking at what they say, Carla should be 400 metres away from school because she can walk 100 metres in a minute. And Liam should be 450 metres away from school. Okay, and we should be able to fill in the rest of that information then. 2 minutes, so Carla would be 300, 200, that's 3 minutes. And, you know, we can do 4 minutes as well. Carla would be 100 metres. Obviously, Liam will get there a little bit quicker, so he will be 300 there and 150 there and 0. He's at school in 4 minutes. Okay, so when we're looking at this then, what we can see here is that when we're looking at the difference, well, our difference, you know, when we're using our TN formula, so let's just take our TN formula first of all. TN is equal to A plus N minus 1 multiplied by D. And what I want to show you here is that sometimes the TN formula can be a little bit confusing, particularly when we look at time. So it's really important that when we're looking at time, just to keep something in mind in relation to A. So A is always our first term. And if we're looking here, sometimes we'll have students who'll say, well, our first term is this term here, because it's always the first term of our sequence. But if I'm to call what that actually is, that's T0. So that is when I am, or Carla or Liam are at home and they have had no, n is equal to 0 itself. And what we've been used to is we've been used to starting with n equal to 1. So this one here would be my T1. Okay. And there's a really simple way of figuring out how to, if you've done this wrong or if you've done it right. And I'm going to show you an alternative method as well. So let's say, for example, we put in, I'm going to do it wrong first of all. So let's say we're going to find out Carla's time. So A is equal to 500. We're going to pretend that 500 is the first term. And that our difference, well, we know that Carla can walk 100 metres in 1 minute. And we can see that that's going down by 100. So I'm going to pop that in there. Okay, so if I pop this in, so Tn equals to my A is going to be 500 plus N minus 1. And my D is minus 100, and again I'm going to pop that in brackets. Well, when I multiply that out, I get Tn is equal to 500, and that's going to be minus 100n minus 100n. So again, just as a quick recap, it's going to be 100 multiplied by n, and then I have minus 100 multiplied by n. Then I'm going to have minus 100 multiplied by minus 1, which is going to give me plus 100. And I'll get Tn is equal to 500 plus 100 is 600 minus 100n. Okay, so that's my linear equation. Now, remember I had said to you before, what we should always do here is we should check. So if I check my TN formula now, what I'm going to get, so if I check here, so let's say I check my first term and I say T1 equals to 600 minus 100 by 1. I will actually get 500, okay? But unfortunately, when we look at that, what that's telling me is that after 1 minute, Carla is 500 metres away. And we can see that that's not true. That Carla is actually just give you a different colour pen. So Carla is 400 meters away. Okay, so what we need to make sure when we're doing a TN formula and we're using time, particularly if there's a start point. So sometimes we're going to see this with meters from school and there's a walking distance in time. It might be something like you're saving money and next, you start with €20 and each week you add €10. So you just have to be really careful with time with these. If we're doing this one here, a really simple way of correcting it, so if you really wish to use the TN formula, a really simple way of correcting it is just making sure, so I'll just make that really small. Okay, so this is the incorrect way. Just going to pop that there, incorrect. So you would need to make sure that you know that your A is equal to your first term is 400. That's where she is after 1 minute. And then your second, or your difference, is still going to be the same. It's still going to be minus 100. And when I stick that into my TN formula, then I'm going to get 400 plus n minus 1. And my D is minus 100. And then I'll get Tn is equal to 400 plus 100. Because we have 1 minus 1 by 1 gives me plus 100, and I have minus 100 by n, so I'm just skipping a couple of steps here. You should be okay to follow this because we've had so much practice on it. And then finally I get Tn is equal to, so 400 plus 100 is 500 minus 100n, small n. Okay, so that would work then. So if I put 1 in here for n, then what would happen is if I put in 0 for n, so no time, then what would happen is I get 500 minus 0, which will give me 500. So I'm not worried about that then. I know that that's correct. Okay, so that can be a little bit confusing. It is something you have to be careful of. But we're going to talk about another type of formula that you could use when you're looking at something to do with time. Okay, so for something like this where you have time involved, the best thing to do is, and it's not really a formula as such, it's kind of just a method. First of all, find the start term. So the start term, if we're looking at making a formula that's going to represent Carla and Liam walking school, well, the start term for Carla is 500 meters, 500, and the start term for Liam is 600. The second step is to find the change or the difference. So our first step was to find our first term, which is for the both of these guys, or the starting point. So probably just to not confuse it, let's call that start point. That would be a little bit better. The second thing we're going to find is the change or difference. So we know that for Carla, the change, the difference for Carla is minus 100. And for Liam, the difference is minus 150. Okay. And the other thing I say here is this change will always be attached to a variable. In our TN formula, that variable was always n. So we would have had 2n, 3n, so on. When we did it on the last slide, we had Carla was minus 100n. And the last step we have here is put these together to create a formula. Don't forget to state what your variables represent. So what I'm going to do is I'm going to call Carla's formula is going to be C. So I'm just not going to use Tn here, okay? So C instead of Tn. And I'm going to say that Carla starts at 500 and she walks 100 meters per minute. So she decreases her distance by 100 meters per minute, and I'm going to represent the minutes as n. So C is equals to Carla's distance. This is me stating what my variables represent, and n is equal to time. So you can see from that formula, if I put in 1 minute in here into my formula, I'll get 500 minus 100, which will give me 400, and I know from my previous table that's exactly where Carla was at that time. Here I'm going to, for Liam then, so if you want to pause the video and try Liam's formula for yourself, pause it now. Okay, so Liam, I'm just going to call L Liam equals, his start point is 600 and he changes by 150 and that's per minute, so I'm going to use N here. And you can use M, you can use T, it doesn't matter as long as you state what your variable is. So I have L equals Liam's distance and N equals time. And I'm going to show you an exam question now on how to do this. Okay, so here is a typical exam question where they've asked about time. So we have Pete and Maeve are saving to buy an Xbox. Pete has saved €20 to begin with. So that's key information, €20. He then saves a further €12 each week. So it might help here if you, so you can see, find the total amount of money Pete will have saved after 5 weeks. So it might help here for you to do your start point, which is 20. And that's going to be, if he saves €12 next week, so that start point, by the way, is 0.0. Okay, so at 0 weeks he has 20, and after the first week he has 32. On the second week he has 44. I'm just adding 12 each time because that's what they've told me. On the third week I have 44 and 12 gives me 56. On the fourth week I have 68, and on the fifth week then I have 80. So this is week 5. Okay, and that's the answer to that question. So all I did there was just added €12 each time to figure out what I would have after week 5. Notice how this is my 0 time, 1, 2, 3, 4, and then that's week 5. Okay, because Pete started out with €20. Now for the next part, write an expression in N for the total amount of money that Pete will save after N weeks. Okay, so using my steps as before. So step 1, start point. So my start point for Pete is this my start point? He started out with €20. Okay, so that's what he started with. My step 2 is my difference. So we know that it increases by €12 each week. So that's plus 12. Okay, before we had, we were talking about distance. So that distance decreased by 100 meters for Kira and 150 meters for Liam. Okay, and then my step 3 is to put that formula all together. So I am going to call P for Pete equals 2. So I'm going to put down my start point first, which is 20, plus, because I have a plus 12 here, okay, 12, and they've told me to use N as the number of weeks. Okay, now I always make sure and double check that. So if I let N equal to 0, that is Pete not having, the very beginning, Pete not having saved any money, what I'll get is P is equal to 20 plus 12 by 0, which will give me 20. Again, if I put N equals to 1, so how much after a week? We already know it's 32, but let's check it. P is equal to 20 plus 12 by 1 equals 32. And just don't forget to put here, P is equal to the total amount of money. Now, they have that already there, so what I can really just put in to my box up here is 20 plus 12N. So again, just to reiterate that your 20 is always your start, or the 20 in this is going to be your start point. Okay, and then you have a change per week of €12. Okay, so have a go at this question. Maeve has saved €15 to begin with. She saves a further €6 each week. write an expression in N for the total amount of money Maeve will have saved after N weeks. So if you want to start off with here, writing out your sequence, so you know that at 0 weeks, Maeve will have €15 to start off with. And after the first week, you can add 6 onto that, so she'll have 21. And you can write out the rest of the sequence if you think it will help you. So press pause in the video now and press play then when you're ready, and we'll have a look at it. Okay, so what I'm going to do here again, step 1, write my starting point. So my starting point is that Maeve had €15 to begin with. Okay, my step 2 then is that it increases by 6 each week, so that's going to be plus €6. Okay, I'm just writing the euro signs in here just that you're not as confused. And then part 3, put it all together. So if I want to put that all together, so again, if I was writing out a full formula here, I would put M equals to 15 as my start point plus 6, and they've asked us again to use N to represent the weeks, so I'm just going to put N there. That's a formula, that's an equation, if this is what they've asked for as an expression. So all they want you to put in here is 15 plus 6N. And again, I can double check that. So for example, I found out that after the first week, Maeve would have €21. So if I pop that in as N is equal to 1, I should get 15 plus 6 by 1, which will give me 21. Now, if we were told that Maeve was going to save for 50 weeks, then if I wanted to find out how much she would have N is equal to 50, I would have 15 plus 6 by 50 equals, and I'm going to pop that into calculator. Well, 6 by 50 is 300 plus 15 is 315. Okay, so it just makes it a little bit easier than me having to write out 50 times, adding 6 on every time. So plus 6 plus 6 plus 6 just makes it a little bit easier.